Hello everyone, welcome to my series of run-throughs going through the O-Level papers. Okay, today we shall be looking at the Science Chemistry paper from October-November 2023. Right, so let's get right into it. Okay, as with all my run-throughs, okay, each question will have the specific topic where they come from, so that if you realize you are struggling for that particular topic, you know which topics to revise to improve yourself. Alright, so for the first one, usually for the first question in the science chemistry paper, it will be a general question where they will test you on concepts for multiple different topics. And in this paper, there are a few questions which are quite general, where they don't focus on a specific topic. So this is the first one. Right, so we have a whole entire list of substances here. So each substance can be used once, more than once, or not at all. And identify the substance. I'm going through this quite slowly because certain common errors that students tend to make is, for example, this kind. All these are singular verbs. Forms, reacts, oxidizes. So if you write multiple, more than one, even if in that example you write two answers for each, even if the correct one is inside your two answers, it will be marked wrong. Alright, because you're supposed to just identify one. Right, so be careful when reading questions. For this case, each of them you just need to identify one. There might be questions where they ask you to identify more than one. So read carefully whether it's a singular verb or a plural verb. Alright, so identify the substance which forms a white precipitate in lime water. I hope this is an obvious one. This would be carbon dioxide. Carbon dioxide. Alright, so reacts with bromine in an addition reaction. So the key word here is your addition reaction. So this is unique to alkenes. Right, and so the only alkene in the list is ethene. And next, oxidizes acidified ethanol to form ethanoic acid. Alright, so the oxidation reaction of ethanol to ethanoic acid, there are two. One is from atmospheric oxygen, and another one is using an oxidizing agent. Since there is no oxygen in this list, so we need to have a oxidizing agent, and the only oxidizing agent here is potassium manganate 7. By the way, potassium iodide is a reducing agent. So the only one here is potassium manganate 7. Alright. So as you can see, for this first question, a general question, it covers quite a few topics. There's redox, oxidizing agent, reducing agent, there's QA, and also there's organic chemistry. Alright, now question 2. It's under the fuels and crude oil topic. However, for the 2024 syllabus, this topic is not so heavy because you don't need to memorize each fraction and what are the uses. So you just need to know that for petroleum, is separated by fractional distillation, and the lighter fractions with the lower boiling points will be at the top, while the heavier fractions with higher boiling points will be at the bottom. So we have petroleum after undergoing fractional distillation. We have these 4 fractions. There are actually 7, but this question only focus on 4. And process A, okay, when you take a fraction to break it down further to get smaller hydrocarbon molecules, alkenes and hydrogen. Okay, I hope you can recognize that this is cracking. Alright, okay, cracking is used to meet the demand, okay, for the smaller fractions, okay, such as petrol and paraffin. Alright, because naphtha and diesel, example, or bitumen and lubricating oils, okay, we can obtain from crude oil, but they are not much in demand. Okay, the ones that we need more would be petroleum gas, paraffin. So you take the larger fractions and you break it down to smaller fractions, and this process is called cracking, yeah, which we will go through later. Right, state the physical property on which fractional distillation depends. Alright, so it's separated by different boiling points. Okay, alright, so these two no longer in your syllabus. Alright, so I will still go through, okay, but one use of paraffin and the kerosene fraction, okay, is fuel for aircraft, okay, fuel for cooking or heating. Okay, alright. And actually in the past we actually use kerosene, okay, as lamps, the fuel for us to have lamps, oil lamps. Okay, state the name of one other fractions not named inside. Okay, yeah, so actually there's quite a few. We have the petroleum gas, okay, lubricating oils, and bitumen. Okay, alright, oh, sorry, to be clear, either. Alright, same thing, this question requires one. Alright, so okay, just give one. Alright, if you give multiple, okay, and if any of them are wrong, okay, you might be marked down. Okay, so name process A, as I mentioned. Alright, so process A is cracking. Alright, when you take a fraction, okay, to produce smaller fractions, okay, which are in higher demand, and it's also the only way to produce alkenes. Right, cracking. Right, so why is it important in the petroleum refining process? Okay. Alright, cracking is used to meet the demand for the petroleum fractions with smaller molecules. Okay, all right, one more thing is cracking is also used to obtain alkenes. Okay, which are useful to make other products. Okay, alright, yeah, but I think the main one is this one. Okay, yeah, cracking is used, okay, to meet the demand for the petroleum fractions with smaller fractions. Right, moving on, we have the topic on ionic bonding, specifically focusing on potassium oxide. Right, solid potassium oxide is a lattice of potassium ions and oxide ions. Okay, describe how a potassium atom becomes a potassium ion. Alright, so okay, a potassium atom, what happens to it when it becomes an ion. So what you need to know is the electronic configuration. Okay, so if you look at the periodic table, okay, potassium has a proton number of 19. So the electronic configuration is 2881. Okay, so in order to obtain a stable noble gas electronic configuration, it will lose one electron, okay, to form K plus, which is 288. Okay, oxygen on the other hand, okay, proton number 8, so the electronic configuration is 26. Okay, the oxygen atom will gain 2 electrons to form 28 to form the oxide ion. Alright, so for the potassium atom, okay, you will lose 1 electron, okay, to form an ion of 1 plus charge. Okay, alright, next, okay, 3a part 2, describe how an oxygen molecule becomes 2 oxide ions. Okay, I remember when I first read this question, oh, this is slightly new, okay, we've never seen this kind of question before. Yeah, so usually they will ask about the atom becoming the ions, but in this time, okay, they ask you oxygen molecule O2. Yes, because oxygen element is a diatomic element. It exists as 2 atoms combined, yeah, so O2, so it becomes 2 oxide ions. Yeah, so you need to talk about how the molecule actually gains 4 electrons, because 1 atom gains 2. So since I have 2 atoms, you need to talk about their molecule gaining 4 electrons, and each of them will form an ion of 2 negative charge. Yeah. The oxygen molecule gains 4 electrons, okay, to form 2 oxide ions, each with 2 minus charge. Okay, also notice, alright, I did not elaborate further, okay, by example saying in order to achieve a stable noble gas electronic configuration. Alright, because this question only requires you to describe, okay, doesn't require you to explain why. Yeah, so do not waste time, okay, when answering chemistry questions. If they don't ask you to explain, okay, you don't need to give reasons why or provide further elaboration. Alright, you just describe the process as it is. Alright. Alright, next, this is a pure memorization question, B and C and even D. Alright, yeah, so you do need to memorize certain things in chemistry. Alright, yeah, like the reason for the properties of ionic compounds, yeah, okay, and yeah, like types of oxides. Yeah, so memorize what you need to memorize, and you can score 4 marks. Okay, yeah, just like that. Okay, which is quite significant. Okay, it can be 1 grade. Alright, so potassium oxide has a high melting point. Explain in terms of structure and bonding why potassium oxide has a high melting point. Alright, so as is mentioned here, solid potassium oxide has a lattice structure. Yeah, so we can write that. Okay. has a giant ionic lattice structure. Okay, how I teach my students to memorize this part is, okay, when there is high melting point, okay, it means it requires a large amount of energy. Why? Because you need to overcome the forces of attraction. Yeah, so when the question is about melting points, be it high or low, okay, the two things that you must think about is the energy required and the forces of attraction involved. So in this case, a large amount of energy is required to overcome the alright, so since you need a large amount of energy, and the next part is to explain the forces of attraction. Yeah, so because you need a lot of energy, the forces will indeed be strong. Yeah, and you don't just write strong forces of attraction. Okay, I want you to remember now when we talk about the forces of attraction, when it is a high melting point, ionic bonding, it is strong electrostatic forces of attraction. Okay, alright, conversely for covalent molecules, okay, it will be weak intermolecular forces of attraction. For ionic compounds, it is strong electrostatic forces of attraction. Yeah, so get those two phrases memorized in your head. Okay, strong electrostatic, weak intermolecular. Don't mix them up. Don't say weak electrostatic and then strong intermolecular. Okay, that will be wrong. Alright, so a large amount of energy is required to overcome the strong electrostatic force of attraction. Not good enough. Between okay, positive and negative ions. Oh, no space. Okay, alright, yeah, so another phrase that you can use instead of positive and negative ions is the strong electrostatic force of attraction between oppositely charged ions. Yeah, this will be a complete answer. Right, once again, a memorization question. Okay, I apologize for the school bell. Alright, next up, C. Okay. Alright, so describe how liquid molten potassium oxide conducts electricity. Alright, yeah, so 1 mark question. Okay, I don't need to talk about the solid state, okay, because this question is asking me to describe for the liquid state only. Yeah, so very important, okay, reading the question. So if you're talking about the solid state, okay, you're wasting time, that's one. Or, and if you describe it wrongly, you might actually be marked wrong. Yeah, so for things that are not necessary, okay, don't need to write. So so how does liquid or molten potassium oxide conduct electricity? Okay, molten potassium oxide conducts electricity due to free moving ions. Alright, yeah, so the solid state, in the solid state, the ions are closely packed together in a regular arrangement, okay, and they vibrate at fixed positions. The key word here is they are in fixed positions. Therefore, they are not free moving. Okay, to conduct electricity, you need free moving charge carriers. Okay, the charge carriers can be electrons or ions. Okay, for metals, the charge carrier that conducts electricity is electrons. For ionic compounds, you don't have free moving electrons. Yeah, and in the solid state, the ions are also not free moving. but once you melt it, okay, molten state or in liquid state, okay, the ions can now slide over one another, okay, because that's the movement of particles in the liquid state, and since the ions can now move freely, they can conduct electricity. Right, this is the same reason why aqueous, okay, ionic compounds can conduct electricity, okay, because in the aqueous state, okay, the ions dissolve in water and can freely move. Right, next, predict whether potassium oxide is acidic, basic or neutral oxide. So simple, it's a basic oxide. Okay, explanation. Okay, potassium is a metal. Okay, metals form basic oxides. Okay, I apologize if you hear some noise from the classroom outside. Okay, yeah, so this is question 3. Alright, 4 marks of which is memorization. Okay, next we have mole concept and stoichiometry. Okay, magnesium reacting with nitrogen to form magnesium nitride. Okay, take note, this is not nitrate, this is nitride. Okay, as shown in the equation, 3 moles of magnesium reacts with 1 mole of nitrogen molecule to form magnesium nitride. Calculate the mass of 1 mole of magnesium nitride. Yeah, so we have mass and mole, and the formula triangle would be, okay, mass, mole and mR. Yeah, so you need the number of moles, okay, multiplied by the mR, and the moles are given, so 1. So actually this question is just asking essentially what's the mR of magnesium nitride. Yeah, so mR of Mg3N2, okay, would be 24 times 3 plus 14 times 2. Okay, right, oh, we get 100 exactly. Okay, yeah, so mass of 1 mole of Mg3N2 will be 100 times 1, which is 100 gram. Okay, by the way, mR has no units, okay, but once you multiply with mole, you get grams. Okay, calculate the minimum mass of magnesium needed to make 250 grams of magnesium nitride. Alright, so this is the stoichiometry question. Okay, Mg3 and 2. Alright, so okay, the question is asking what is the mass of magnesium needed, okay, to make 250 grams of magnesium nitride. Alright, so the method I'm going to show is what I call the junction method. Okay, so we have the starting point and the ending point, the destination. Yeah, so from any starting point, okay, you always need to visit a certain junction before you can go to the ending point. Okay, and that junction is the mole. Alright, whatever you are given, okay, you need to convert to mole, okay, because in a chemical equation, okay, the coefficients refer to the mole ratio. Okay, they don't refer to the mass ratio, okay, or they don't refer to the volume ratio for certain things. Alright, yeah, so you need to convert to mole first. Alright, so given the mass, how do I find mole? And true enough, we have done this. Right, so to find mole is mass divided by mR. Okay, in this case, we have found the mR in part A, which is 100. So I get 2.5 mole. Okay, Now in our way to our destination, okay, we need to find the number of moles of magnesium, and as you can see, the mole ratio is 3:1. So if 1 unit is 2.5, 3 units would be 7.5 mole. And lastly, you need to find the mass. So given mole, to find mass, you need to multiply by the mR. And in this case, please remember the coefficient is not part of the formula. Okay, magnesium is just Mg, not 3 mg. Okay, I will write times mR here, but because this is just a atom, I would just times AR. Okay, it's 1 atom. Okay, the coefficient, okay, in this case 311, okay, is not part of the formula, and I think this is a common mistake by students. Okay, you would actually multiply by 24 times 3. Okay, but actually magnesium is just 24. Right, a good way to remember is when I ask you what is the formula of water, okay, you give me H2O. Alright, you don't say 3H2O. Yeah, because the 3 is part of an equation when balancing, for example. Alright, okay, the coefficient is not part of the formula of water. Same thing here. Okay, magnesium, the formula is Mg, not 3 mg. Yeah, so mass of Mg, okay, would be 7.5 multiplied by 24. Okay, and I get 180 grams. Right, quite easy. Okay, yeah. Okay, next, part C, we switch to atomic structure. Alright, we have the nitrite ion, N3 negative. Alright, so let's revise. The smaller number is your proton number, okay, and the bigger number, alright, is your nucleon, or sometimes known as mass number. Okay, and your nucleon number is the number of proton plus number of neutrons. Okay, yeah, so we have the number of protons, we have the number of neutrons. Now we need to find the number of electrons. Okay, and as you can see, alright, this is 3 negative. Okay, so 3 negative means you have gained 3 electrons. Okay, right, so in atom, okay, proton number is equal to number of electrons. Okay, an atom is electrically neutral. Okay, the proton number and the number of electrons would be equal. Yeah, so if I have a nitrogen atom, okay, it will be 7 proton, 7 electrons. But once you form an ion, okay, the number of electrons change, so no longer will the proton number be equal to the number of electrons. Yeah, so in ion, okay, proton number is not equal to number of electrons. Okay, this is just me doing a little bit of revision. Alright, so we can find the number of protons, the easiest one. Okay, the number of neutrons would be 15 minus 7, 8. Alright, electron, okay, so usually the atom would only have 7 protons. Okay, but because I have gained 3, it will be 10. Okay, alright. Okay, some people might be confusing nucleon number with relative atomic mass. Okay, the relative atomic mass of nitrogen is 14. Okay, but how come this one is 15? Okay, please remember, relative atomic mass is the average mass of all the isotopes of nitrogen. Okay, it just happens that if I take the average of all the nitrogen isotopes, okay, I can have nitrogen 15. Okay, I can have nitrogen 14, I can have nitrogen 13. Okay, a large chunk of nitrogen isotopes is actually nitrogen 14. So when I take the average of all the isotopes, okay, I get a number which is very close to 14. Alright, so that's why in your periodic table they give it as 14. Okay, yeah, so nucleon number and relative atomic mass, they are related but they are not equal. Okay, nucleon number is specific for each isotope. Okay, I can have 15, I can have 14, I can have 13. Okay, but relative atomic mass is the average of all the isotopes. Okay, depending on the proportion of each isotope. Okay, which you don't quite need to know actually. Alright, that's a pure chemistry concept. Alright, just need to know that they are related but they are not equal. Yeah, it's a common misconception. Right, next. Okay, we have qualitative analysis. Alright, this kind of question, okay, where there's a flow chart. Okay, is quite a common type of qualitative analysis question. Right, so we have products STU formed by chemical reaction of mixing two metal oxides R with hydrochloric acid. Okay, it also shows some of the chemical reactions for S and T. Alright, so I have metal oxide react with acid. Yeah, so this will be your neutralization reaction. So I have two different solutions and a colorless liquid. Alright, so metal oxide plus hydrochloric acid, that will be your neutralization. Okay, so please remember, metal oxides are bases. Yeah, and base plus acid, you get salt plus water, and that would be U. Okay, U would be water. Next, okay, I have a green solution and a yellow-orange solution. Alright, once you see green solution, okay, maybe it is iron 2. It contains iron 2 ions, okay, but it can also be copper 2 because certain copper 2 compounds do form a green solution. Alright, when you see a yellow-orange solution, okay, alright, most likely it will be it contains an iron 3 ion. Alright, so let's see. I have this green solution. So and it's sodium hydroxide. This would be your cation test, and I get a green precipitate. Yeah, so confirm that this one is, it contains iron 2 plus. Okay, and the green precipitate, please remember, for any cation test, okay, the precipitates are your hydroxide. Okay, iron 3 hydroxide. Sorry, iron 2 hydroxide. Okay, for T, this is also a cation test. Okay, alright. Okay, I get a red brown precipitate, so this is iron 3 hydroxide. Okay, please remember, for your cation test, regardless if it's sodium hydroxide or aqueous ammonia, alright, the precipitate for cation test is the hydroxide. Okay, please remember that. Alright, and I have aqueous silver nitrate. Okay, this is your chloride test. Yeah, so there's white precipitate, so that means, by the way, sorry, just to add, so this is iron 3 plus. Okay, and since there's white precipitate, that means the silver reacts with the chloride, okay, inside T to form the white precipitate of silver chloride. Okay, that means T contains chloride. Okay, which makes sense because from the oxide, okay, you react with hydrochloric acid, so okay, the salt that you get is the chloride. Okay, yeah, so actually this one also contains chloride. Yeah, so we have iron 2 chloride for S and iron 3 chloride for T. Okay, Right, okay, let me repeat, okay, in case that was too fast. Right, so I started off with two metal oxides which are bases, okay, and when they react with acid, okay, that's your neutralization reaction. So base plus acid, you get salt and water. Yeah, so the colorless liquid will be water, and I get two salt solutions, okay, and using the cation test, I identify that the solutions contain iron 2 and iron 3 ions, okay, and that actually between both of them, because they react with hydrochloric acid, they also contain the chloride ion, which will give a white precipitate with silver nitrate. Alright, okay, next, so we can write all the answers down. Okay, just a note, okay, if the question says identify, you can use both the chemical formula or the chemical name. Okay, but if the question says name, okay, you cannot use the chemical formula. For me, okay, my advice to you is just use the chemical name. Alright, because it is easier. Okay, it's because some people, when trying to do the chemical formula, okay, they make careless mistakes, okay, then they get it wrong. Yeah, so you can just write the chemical name, and that tends to not cause much trouble. Yeah, so S would be iron 2 chloride, T would be iron 3 chloride, okay, alright, U would be water, V is iron 3, oh, let me change my pen, excuse me, I apologize, where were we? Okay, yeah, V is iron 2 hydroxide, okay, W is iron 3 hydroxide, and X is silver chloride. And therefore identify the two metal oxides in mixture R. So we have iron 2 oxide and iron 3 oxide. Okay, write a balanced chemical equation including state symbols for any of the reactions shown. Okay, there's quite a lot of reactions here. Okay, alright, you can do the neutralization reaction. Okay, alright, you can do the precipitation reactions. Okay, I think I'll just do a few examples. Okay, let's do the iron 2 oxide reacting with hydrochloric acid. Alright, so iron 2 oxide, okay, Fe2 plus and O2 minus, okay, plus hydrochloric acid, okay, I will get iron chloride, iron 2 chloride, and water. Okay, as you can see, I leave space, okay, before and after each substance, okay, because I will need to write the state symbols and also to balance. Okay, yeah, so 1 iron, 1 oxygen, 2 hydrogen on right side and 2 chlorine on right side, so I require 2 hydrochloric acid. Okay, metal oxides are ionic, so they have high melting point, so solid. Acids are aqueous, take note, not liquids. Okay, and water is liquid. Okay, and the salt is aqueous, right, because you form a solution. Okay, most salts are soluble. Okay, alright, most salts are soluble except those that can form your precipitates. Yeah, and also this is a solution. Yeah, so it's aqueous. Okay, I chose this is because the one with iron 2, okay, the balancing would be more difficult. Alright, okay, let me show you one for the precipitation of the green precipitate. Okay, yeah, so we have sodium hydroxide, okay, Alright, so I get iron 2 hydroxide. Okay, and the leftover would be sodium chloride. Okay, please take note, the precipitate is insoluble, so it's solid. Okay, that's why you can see it. Alright, okay, and what's left over would be the ones that actually spectator ions. So iron and hydroxide, iron 2 and hydroxide react to form the precipitate, the green precipitate, and you're left with sodium and chloride ions, so they form sodium chloride. Okay, as you can see here, it's not balanced. I need 2 chlorine. Okay, and I've changed the number of sodium, and I need 2 sodium, and good enough because 2 OH, okay, is already accounted for. Yeah, so this is the balancing. Alright, yeah, okay, maybe one more. Okay, for the iron 3 reacting with silver nitrate. Okay, so I have silver nitrate. This is another precipitation reaction. Okay, you get silver chloride, solid, and iron nitrate. Iron 3 nitrate. Okay, yeah, so to balance, okay, but you require 3 3. Yep. Okay, yeah, if you want to try the iron 3 oxide reacting with hydrochloric acid, okay, you need to balance. That will be a bit more difficult. Yeah, same with the cation test for the iron 3 chloride. Okay, but you can try. Okay, I gave you 3 examples. Okay, yeah, question 6. Oh, this is a general question. Okay, because it's asking for, okay, things from different topics. Right, I have citric acid C6H8O7, which reacts with carbonates and with alkalis. Okay, this is the equation between citric acid and aqueous sodium carbonate. Predict using the state symbols one observation of the reaction. Okay, this is a simple question. Alright, it might look like what is this question asking? Alright, but if you look at the state symbols, okay, for the reaction, once you see, okay, a gas produced, okay, what you can see is effervescence. Effervescence is observed. Okay, yeah, so once you produce a gas, you will see effervescence. Okay, not all reactions have effervescence. Only those reactions that produce a gas, okay, in solution, okay, alright, then you can see effervescence. Okay, example like the previous one, base plus acid, you get salt and water. Okay, you will not see any bubbles, okay, because there's no gas being produced. Okay, the reaction takes in heat from the surroundings. Okay, so the type of reaction that takes in heat from the surroundings is the endothermic reaction. Okay, describe how universal indicator is used to estimate the pH of aqueous citric acid. Alright, so you add a few drops of universal indicator to citric acid. Okay, then you compare the color of the solution with the pH chart. Okay, of universal indicator. Alright, yeah. So the basic idea for this question is describing how a universal indicator work. Alright, so when you add universal indicator, alright, you get a change in color. Universal indicator is green when neutral, okay, and citric acid, okay, so it will be acidic, so it will be like red, orange, or yellow, but red is for the strong acid. Okay, citric acid is actually a weak acid. Okay, it's the acids found in lemons and oranges. Yeah, so I would expect the color to be orange or yellow. Yeah, so but since they are just asking how do you estimate the pH, okay, yeah, so you need to compare the color, okay, to the pH chart, okay, that is given in the universal indicator. Alright, citric acid is neutralized by alkali sodium hydroxide. Write the ionic equation for this neutralization reaction. Okay, this one memorize. Okay, neutralization reaction. Okay, the ionic equation is H plus from the acid react with the hydroxide from the alkali to give water. Okay, no matter what acid or alkali, okay, the neutralization reaction ionic equation will be this one. Right, yeah, so just memorize and write. Okay, alright, next we have air pollution. Okay, alright, we have carbon monoxide, okay, nitrogen dioxide, nitrogen monoxide, and sulfur dioxide are pollutants found in the atmosphere. Okay, name one other atmospheric pollutant. Okay, we have methane, okay, unburnt hydrocarbons. Okay, yeah, so or so one of them. Okay, yeah, okay, because they say only one other. Alright, complete the table. Okay, so by the way, these 5 marks are just memorization. Okay, memorization. Yeah, so apologize again for the bell. Yeah, so 5 marks. Okay, that's like a jump of 1 grade. Yeah, so nitrogen dioxide, NO2. Okay, source of pollutant. Okay, alright, so yeah, high temperatures. Okay, in car engines. Okay, or you can also say lightning activity. Okay, also produces oxides of nitrogen. Okay, sulfur dioxide. Okay, combustion of fossil fuels such as coal. Okay, coal contains impurities of sulfur. Therefore, when you burn coal, okay, not only do you get carbon dioxide, you also get sulfur dioxide. Or you can say volcanic activity. Yeah, so for nitrogen dioxide, you can say lightning activity. For sulfur dioxide, you can say volcanic activity. Alright, yeah, I'm giving the man-made sources of the pollutants, not the natural one. Yeah, so carbon monoxide, effect on health and environment. Okay, carbon monoxide do not contribute to acid rain, okay, because it's actually neutral. Alright, so effect on health. Okay, it is toxic to humans. Okay, leading to breathing difficulties. Right. Yeah, so this is the effect and sources of the 3 main pollutants that you all need to know. Okay, memorize. Okay, alright, this can actually give you a jump of 1 grade. Okay, next we have redox. Okay, carbon monoxide and nitrogen monoxide are both made in a car engine. Hey, alright, yeah, which is actually the same for nitrogen dioxide. Okay, a catalytic converter, when fitted to a car, changes these 2 gases into less harmful gases. Okay, and this is the equation shown. Alright, so explain why the reaction involves both reduction and oxidation. Alright, so let's see, highlight what each becomes. Okay, right, so I can see that carbon monoxide becomes carbon dioxide, so it gains oxygen, therefore it is oxidized, while at the same time nitrogen monoxide, okay, lose oxygen, therefore it is reduced. Okay, right, that's why this is a redox reaction. Right, so reduction, okay, alright, okay, nitrogen monoxide, okay, loses oxygen, and thus is reduced to nitrogen N2. Take note, I did not write the coefficient, okay, not 2NO, very important. Right, once again, okay, nitrogen monoxide is NO, okay, not 2NO. The 2 is the balancing for the equation. Right, yeah. Oxidation, simple. CO gains oxygen, okay, and thus is oxidized to CO2. Right, yeah, so this is the easiest one. If you want to talk about oxidation state, okay, that's a bit more difficult to explain, okay, but you can. Right, for that, in that case, if you want to use oxidation state, right, you must say that the oxidation state of nitrogen, okay, decreases from +2 in NO to 0 in N2, therefore it is reduced. Okay, I repeat again, the oxidation state of nitrogen, okay, decreases from +2 in NO to 0 in N2, okay, therefore it is reduced. On the other hand, the oxidation state of carbon increases from +2 in CO to +4 in CO2, therefore it is oxidized. Okay, the oxidation state of carbon increases from +2 to +4, +2 in CO to +4 in CO2, and therefore it is oxidized. Yeah, as you can see, when you want to write based on oxidation number, okay, or oxidation state, okay, you need to be more precise, okay, and more accurate, like saying +2 in CO, +4 in CO2, increase or decrease. Yeah, so I would rather just explain using oxygen. Okay, and also the question is not being restrictive. It didn't say that you must use oxidation state or oxidation number, so either method is fine. Right, next, rate of reaction. Okay, describe the effect, if any, okay, the increasing the pressure on the rate of reaction at constant temperature. Okay, so I need to look back, okay, at the reaction. Okay, and I see that the reacting particles are gaseous. Okay, therefore pressure would affect the rate of reaction. Yeah, so increasing pressure will, okay, increase the rate of reaction. So explain your answer in terms of collision between particles. This is a typical kind of question in speed of reaction or rate of reaction. They change a factor, you must explain how that affects the particles, which leads to the increase in the frequency of effective collision and then the increase in the rate of reaction. Alright, so okay, increasing the pressure will cause the reactant particles to be closer together. Okay, alright. Okay, if you forget, okay, alright, let's say I have a certain pressure here and I have, okay, 6 particles. Alright, if I increase my pressure, okay, alright, the particles are closer together. Okay, yeah, therefore they will collide more often, and that will lead to an increase in the frequency of reactive collision and lead to an increase in the rate of reaction. Yeah, so increasing pressure will cause the reactant particles to be closer together. This leads to an increase in the frequency of effective collisions, thus the rate of reaction increases. Okay, this is actually another memorization type question. Alright, yeah, so for each factor, example temperature, okay, it affects the particles, okay, and therefore changes the rate of reaction. Yeah, therefore you need to memorize what each factor does. Okay, example, for in the case of temperature, increasing temperature will make the reactant particles move faster. Okay, then it leads to increase in frequency of effective collision, and therefore the rate of reaction increases. Okay, or another one for let's say concentration. Okay, increasing concentration, okay, will increase the number of reactant particles per unit volume. Therefore, this leads to the increase in the frequency of effective collisions and the rate of reaction increases. Yeah, so all this need to memorize. Okay, yeah, so yet another memorization question. Yeah, so memorization is actually quite a key component in chemistry, about 20%. Yeah, so if you want to improve in chemistry, okay, memorize what you need to memorize accurately. Okay, don't just memorize okay, haphazardly. You need to be accurate in your memorization. Okay, section B. Alright, in the 2023 paper, okay, section B, you are given 3 questions, you just need to answer 2. Alright, but for the 2024 syllabus, okay, section B, you are given 2 questions, you need to answer 1. Okay, and yeah, correct. Yeah, so for those taking the 2024 paper, okay, if you're given 2 questions and you just need to answer 1, and if you answer both questions, okay, Cambridge will only mark the first one. Alright, okay, they do not have time to mark both questions and decide for you which one is a higher scoring question. They will just mark the first one. Yeah, so if you accidentally do both questions, okay, choose the one that you do not want and you strike out the entire page. Okay, don't just like cross at the side. Okay, it might not be it might be obvious that you're not attempting that question. Alright, yeah, so for the previous syllabus, you're given 3 questions, okay, then you need to answer 2. Okay, yeah, in this case we have group properties, okay, some KPT and more. We have organic chemistry and a general one. Alright, okay, I will go through all of them. Yeah, okay, so for you guys, okay, if you're practicing, please do all questions. Okay, do not pick and choose. In the O-Level, then you pick and choose. Okay, for now, do all. Okay, practice. Okay, because the topic that you did not choose, okay, might come out easier in your O-Level paper. Alright, so we have different groups in the periodic table. Okay, I also change the group numbers instead of the Roman numerals to the numbers that you're familiar with. Elements in group 17 are called halogens. This question is about group 18 of the periodic table. State the name given to the elements in group 18, and we have the noble gases. Right. Okay, complete table 8.1 by stating the electronic configuration of argon and the proton number for krypton. Okay, alright, so we have argon 18, so it is 288. Alright, and for krypton it's the other way around, so I need to add the numbers. Okay, and I get 36, or I could actually use the periodic table, okay, to find the proton number for krypton. Right, done. Okay, easy 3 marks so far. Okay, explain why elements in group 18 are chemically unreactive. Another memorization question. Okay, alright. The valence, or you can say outermost, okay, shell, okay, or each group 18 element is completely completely filled. Yeah, or you can say the outermost shell of each group 18 element is fully filled. That will be okay. Alright, yeah, another memorization question. Okay, describe the pattern shown. Okay, instead of pattern, they might also use the word trend. Alright, describe the pattern shown by the melting points in the elements in group 18. Okay, you need to be careful. These are negative numbers. Alright, although the magnitude of the number seems to be going down, since this is negative numbers, okay, actually the melting points are increasing. Okay, alright, so down the group, okay, the melting points increases. Okay, please take note. Okay, you must say the direction. Okay, and usually we start off with down the group, okay, because that's easier to read. Okay, alright. Kinetic particle theory. Okay, describe using kinetic particle theory the changes in motion and arrangement of neon atoms when the solid changes to gas. So we need to focus on motion and arrangement. Okay, and when you see the word changes, okay, this applies to all science subjects. Okay, you need to talk about the before and the after. Okay, in this case, the before is solid and the after is gas. Okay, yeah, so I will talk about the motion arrangement in a solid, then I compare it with the motion arrangement of the gas. Okay, alright. In the solid neon, okay, alright. Alright, by the way, I usually use the word particles, okay, but because these are noble gases and they use the word atoms here, okay, they are monoatomic elements, yeah, so I can use the word atoms. Okay, yeah, example, if the question is about water, okay, alright, I can just use particles, okay, because water is not atoms, okay, it's a molecule, yeah, so to be more general, you can say particles, okay, yeah, but I want to say atoms, okay. Okay, the atoms are vibrating about fixed positions and are closely packed in an orderly arrangement. Alright, yeah, so I have the movement and I have the arrangement. Okay, please take note, for arrangement you need to talk about the distance between the particles and also whether they are orderly or disorderly arranged. Okay, yeah. The gaseous neon, or you can say in neon gas, okay, the atoms are moving at high speeds in all directions and are far apart in a disorderly or random, also can, arrangement. Right, yeah, another memorization question. Okay, yeah, so 3 marks. Okay, yeah, so once again, for motion, okay, just need to memorize for solid vibrating about fixed position, gases moving at high speeds in all directions, liquids will be sliding over one another. Arrangement, please remember there's always 2 parts, the distance between the particles, solid closely packed, gases is far apart, and whether they are orderly or disorderly arranged. Okay, so solid is the only one that is orderly arranged. Okay, gases and liquids are disorderly arranged, but for liquids the particles are still closely packed. Alright, a sample of neon gas has a mass of 3.0. Okay, calculate the amount of moles of neon atoms in the sample. Okay. Right, so once again we have mass, okay, moles and mR. Alright, so we have 3 grams. Okay, and to find number of moles we need to divide by the mR, in this case AR, because neon is just Ne. Okay, so if you look at neon, okay, the neon AR is 20, okay, from the periodic table. Alright, so the amount in moles, number of moles would be the mass 3.0 divided by 20, right, 0.15. Okay, next, calculate the volume of 3.0 gram of neon at room temperature and pressure. Okay, right, so for volume of gas is already given here. Okay, volume of gas, okay, is number of moles times by 24. Right, so since 1 mole occupies 24 dm cube, okay, yeah, so you need to find how much volume does 0.15 mole occupy. Yeah, so volume would be 0.15 times 24, and you get 3.6 dm cube. Oh, sorry. Yeah. Okay. Yeah, quite easy actually. I feel this question. Yeah. Yeah, many of it is memorization. Yeah. It's okay. Right. Okay, next, organic chemistry. Right, I have the structures of some organic compounds, right, but you can see they are not the full structural formula. The full structural formula, okay, would be like the full drawings, okay, not just some bonds joined together. Right, compounds that are members of the same homologous series share the same general formula. State the general formula for alkane and identify the alkane shown. Alright, so another memorization question. CnH2n plus 2. Alright, for alkane, and we have two alkanes. Yeah, so you can either write A or D. Alright, yeah. Describe two other characteristics of a homologous series. Okay, yeah, so you can say okay, yeah. Okay, they react or have similar chemical properties. Okay, yeah, I think that's a better one. Sorry. They have similar chemical properties. Okay. They show a gradual change in physical properties. Okay, as the molecules become bigger. Yeah, this will be the two main ones. Alright, so a homologous series, okay, will have the same general formula and have similar chemical properties, okay, or similar functional group. Oh, sorry, to be more precise, okay, have the same functional group, okay, and they will also show a gradual change in physical properties as the molecules become bigger. For example, okay, from methane versus propane, okay, the melting point and boiling points will increase, okay, the viscosity increases but flammability decreases. So those are the kind of physical properties that changes, okay, as the molecules become bigger. I can also write one more, and that is the the member of the consecutive member in the homologous series differs from the previous one by a CH2 unit. Yeah, that one is more abstract, okay, but I think it's quite it will be accepted as an answer also. Right, identify the letter of the compound in figure 9.1, which is a carboxylic acid. Okay, yeah, so carboxylic acid, okay, the functional group is your COOH, alright, which looks like this. Okay, yeah, so please memorize this. Yeah, for this question you don't quite need it, okay, yeah, but the one with COOH is B. Okay, compound E is both unsaturated and a hydrocarbon. State why E is unsaturated. Oh, once again, another memorization question. Alright. It contains a carbon-carbon double bond. Okay, alright. I have seen students write it contains a double carbon bond. Okay, that is wrong. Please, okay, memorize, but memorize accurately. Okay, something is unsaturated, it contains a carbon-carbon double bond. To extend your learning, okay, for vegetable oils, okay, they are polyunsaturated foods, poly being many. So if they ask you why it is polyunsaturated, okay, it contains many carbon-carbon double bonds. Alright, state why E is a hydrocarbon. Alright, it contains only hydrogen and carbon atoms. Okay, in this case, if you never write the word only, you don't get the mark. Okay, that is very important. Alright, because B and C also contains carbon and hydrogen, okay, but they also contain oxygen, so B and C are not hydrocarbons. Yeah, a hydrocarbon contains only hydrogen and carbon atoms. Okay, next, compound E is a monomer used to make an addition polymer. Okay, draw the structure of this addition polymer product. Okay, alright, so this one I will use my pencil. Okay, so we need to look at E first. Alright, I'll do the working, I'll show you the answer later. Okay, E is this one. We have CH3, CH, CH2. Okay, correct. Alright, so I need to redraw first. Alright, so E is actually CH3, CH double bond CH2. Okay, this is typically what you would draw, okay, for the full structural formula of an organic compound. Okay, but for making polymers, okay, you need to modify, okay, the monomer a bit. Okay, alright, you need to make it in this form, okay, where the double bond is in the center, okay, then the other parts are at the top and bottom. Okay, you cannot have it at the sides. Alright, yeah, so you need to modify first the monomer to this form, then you can draw the polymer. Alright, so okay, let's modify. Okay, yeah, we modify this one. Alright, so carbon, carbon, top and bottom. Okay, yeah, maybe I'll draw at the side, no space. Okay, carbon, carbon, 5 hydrogen at the top. Okay, alright, so these two are alright, these are the easy ones. The bottom I don't have yet. Yeah, so what can I do? Okay, I can actually move this below, therefore I get hydrogen here. Okay, and this entire thing, okay, you see this bond here. Okay, alright, I can move it down. Okay, and I will get CH3. Alright, yeah, this is what happens. Okay, yeah, so this entire thing I can move down and collapse the okay, the formula CH3 into, instead of drawing it out, okay, I make the shortcut, okay, CH3. Now I have the monomer. Okay, whether this is just working, the answer would be here. Okay, yeah, so actually this you can do it at the side, okay, or something. Alright, yeah, the final answer would be this. Okay, yeah, so I would have the monomers side by side, CH3H. Alright, I'm gonna repeat 3 times. Okay, yeah, so I have 3 units of the polymer. Okay, and I extend the line. So if you forget, addition polymerization is, okay, when you have multiple alkenes, okay, alright, okay, they each open up their double bond and connect, okay, with those to their left and to their right, and they form one long chain, okay, and that long chain is called a polymer. Alright, yeah, so this is the answer. Okay, yeah, 2 marks. Yeah, I think many students struggle in drawing the modified monomer to form the polymer. Yeah, so once again, draw out first. Okay, then you need to change it to have the form of the double bond with top and bottom parts. Yeah, then you just compare, how do I make the top parts and how do I make the bottom parts. Okay, draw a dot and cross diagram to show the bonding in a molecule of compound G. Compound G is CH4. Alright, this is CH4. Alright, now once again, there's quite a bit of working to do. They even give you the proton number, easy for you. So carbon is 6, 2, 4. Okay, alright. By the way, it didn't say only the valence electrons, so that means I need to draw all electrons. Okay, for covalent molecules, okay, the rule is however many electrons you need, that's however many electrons you share. Okay, I call it the need X, share X rule. So if I have 4 valence electrons, okay, I will need 4 more electrons to be stable, okay, to get to 8. Since I need 4, I will share 4 electrons. Yeah, so carbon will look something like this, 4 electrons. Okay. Hydrogen have 1, okay, and the first shell maximum only have 2, so therefore I will need 1 electron, and therefore I will share 1 electron. So hydrogen will have, okay, 1 that it can share, and since it's CH4, okay, it's actually like this. Alright, so carbon is in the middle, okay, and 4 hydrogens surrounding it. Alright, so to draw, okay, this is the inner shell of the carbon. Okay, and this is the outer shell. Okay, I'm sure many of you can draw nicer dot and cross diagrams than me. Okay. Okay, yeah. Alright, so the inner electrons are not participating in the bonding. Alright, so I need 4, I will share 4, so carbon will share 1 each, okay, to the 4 hydrogens, and each hydrogen will share 1 with carbon. Okay, next, okay, you can see that carbon is already stable. It has 8 electrons in the outermost shell, 1, 2, 3, 4, 5, 6, 7, 8. A common mistake by students is, okay, they would draw extra electrons. Okay, yes, if I have 4 electrons, I share 4 already, that means I will not have any more that are unshared. Similarly for hydrogen, okay, I have 1 electron, I share 1 already, so I will not have any other electrons that are not shared. Okay, the easiest way to to improve in this kind of drawings is to count the number of electrons. Once you get a stable number, okay, it's already stable here, 8. Yeah, I don't need to add any more electrons. Same with hydrogen, okay, I already have 2 electrons, I don't need to add any more. Alright, okay, yeah, so that is for methane. And the last question, okay, this is a general question, but actually it is more for salt preparation, which is no longer inside the 2024 syllabus. Yeah, some parts you can answer, some parts you cannot. Yeah, so okay, yeah, so let's do the parts that you can. So explain why copper sulfate is not prepared from copper metal and dilute sulfuric acid. Or by the way, when they say prepared, okay, they means how is it obtained. Yeah, so insoluble copper oxide reacts with dilute sulfuric acid to form copper sulfate. Yeah, so how do I prepare or obtain copper sulfate? Alright, so you must explain, the question is asking why to get copper sulfate I did not react copper with sulfuric acid. Okay, and the answer is simple. Okay, copper is unreactive to acids. Okay, this is part of your reactivity series. Okay, the 3 metals below hydrogen, copper, silver and gold, okay, do not react with acids. Alright, so the steps to prepare copper sulfate. Okay, once again, prepare is another fancy word for obtaining copper sulfate. First, you add excess of the copper oxide to sulfuric acid. The reaction mixture is warm and stirred. Okay, then I separate the excess copper oxide, okay, from the copper sulfate mix. Right, yeah, so in case you all are not sure, copper oxide reacts with sulfuric acid, you get copper sulfate, okay, and water. Yeah, so I add excess of copper sulfate, okay, after reaction I get copper sulfate and water, okay. And how do I separate the excess copper sulfate from this? Okay, sorry, how do I separate the excess copper oxide, okay, from the copper sulfate solution? Alright, yeah. So first things first, explain why excess copper 2 oxide is used. Okay, this is not in your syllabus, not in your syllabus, so you don't need to know. Okay, alright, but I will still write the answer. Okay, to ensure all the sulfuric acid is reacted. Okay, okay, I will explain why. Okay, but since it's not in your syllabus, okay, I'll just move on. Okay, explain why the reaction mixture is warm and stirred. Alright, so this is simple. Alright, it's to increase the rate of reaction. Alright, if you don't, okay, it will take a while to react. Okay, if you just pour it, then let it sit. Okay, name the experimental technique used to separate the excess copper 2 oxide from aqueous copper sulfate. Okay, the key word is copper 2 oxide is insoluble. Okay, this is insoluble. Okay, and you get aqueous copper sulfate, yeah, so this is soluble. So how do I separate something insoluble from a soluble substance? Okay, is filtration. Alright, next, describe how to make pure dry crystals of copper sulfate from aqueous copper sulfate. Okay, basically this is describing, okay, the steps for crystallization, okay, which you should know. Okay, yeah, so alright, so you heat the solution of aqueous copper 2 sulfate until saturated. Okay, okay, leave the hot saturated solution to cool. Okay, why do you do that? Crystals of copper 2 sulfate okay, will form. Alright, next. Okay, yeah, some students after this, the step that they always forget is to filter to obtain the crystals. Alright, because the crystals, okay, since it's just a saturated solution, okay, there might still be some water left over. Yeah, so you want to remove the water, okay, from the solid crystal, so you need to filter. Okay, filter to obtain the crystals. Alright, and to ensure it's pure, you need to wash with a small amount of cold deionized water. Alright, so wash the crystals with a small amount of cold distilled water. Okay, keywords are it must be small amount and it must be cold. right? Because if you use a large amount of distilled water, you're just going to dissolve the crystals again. And if the water is warm, okay, it will dissolve more. Okay, you just want to wash a bit. Yeah, so you might lose some of the crystals when they dissolve in the washing. Okay, but you don't want to lose everything. Okay, just a bit. All right, so after that, okay, pat dry the crystals between pieces of filtered paper. Right, yeah, so these are the steps of crystallization. Please memorize. All right, okay, yeah. Next, copper is a metal that is often used to make an alloy. Okay, what is the term alloy? Another memorization. Okay, as you can see, there's like 5 marks of memorization questions. Okay, yeah, like I said, 20% of the science chemistry paper is memorization type questions. Yeah, so if you memorize accurately, okay, you can actually improve well. Okay, yeah, all right. So the term alloy, okay, an alloy is a mixture of a metal with another element, okay, or with other elements. Okay, yeah, the main point is a mixture, okay, not a compound, okay, and must have a metal. All right, last part, copper metal is often recycled. Okay, describe 2 reasons why it's important to recycle copper. Okay, this is no longer in your syllabus. What's in your syllabus is recycling plastics. Yeah, so you go study and memorize why and how plastics are recycled. Okay, 2 reasons why you need to recycle metals. All right, I will still write the answers. Okay. Copper metal is a finite resource. Okay. Yeah, metals are actually finite. That means they are limited in the earth. Okay, they are not produced more. Alright, so one day we will run out of metals. Yeah, therefore, like it or not, okay, we need to recycle metals. Okay, because we will run out of metals one day. Okay, and lastly, right. Okay, most metals are found in ores, and you require natural resources. Okay, be it fuels, okay, and other reagents used to extract them from the ores. Yeah, so recycling would conserve those natural resources. So instead of using them to extract, okay, you can just use an old copper, okay, that is no longer viable. Okay, you recycle it, okay, to make it into a new product, okay, without having to extract it from the ore in the earth. Alright, yeah, so there are other reasons also. Example, it is more cost effective, yeah, or it is okay, it does less damage to the environment than extracting from the ores, okay, something like that. Yeah, by the way, this is not in your syllabus anyway. Alright, okay, so that's it for this paper. Overall, I think quite a straightforward paper. Yeah, so I hope that this run through has been quite beneficial to you. Okay, and I'll see you in the next one. Okay, take care everyone.